Hello everyone, I welcome you all for the session on resonance and coupled circuits. In this video, let me explain the basics of resonance and its applications briefly. To start with, resonance is a very important phenomenon, and the study of resonance is very much useful in the area of communications. Actually, the resonance principle is used in radio receivers to select the signals transmitted with one particular frequency of an FM station. For example, let us assume that 5 FM radio stations are broadcasting their signals with the different frequencies. Suppose if we want to listen to the programs telecasted by one particular FM station, we used to tune our radio to one particular frequency. Then the radio receiver will receive the signals with that frequency alone, and all other signals will be eliminated. So here the resonance principle is used. This is a simple example of how resonance is used. For this resonance to occur in any circuit, we require a minimum of one inductor and a capacitor, and they are connected in such a way that the energy transfer happens between the inductor and capacitor. So that circuit is called as a tank circuit. So at that frequency, the energy is exchanged between the capacitor and inductor. Now let us discuss about what is a tank circuit and how oscillations are produced in a tank circuit in detail, because this is the basic for understanding the concept of resonance. Let us consider an already charged capacitor which is connected across the discharged inductor. That is, the inductor has no energy in it. So the initial voltage across the capacitor is E, and the current flowing through the inductor is initial current flowing through the inductor is 0. Now the variation of voltage across the capacitor and the current through the inductor can be drawn as a waveform for better understanding. You can see that the current is at 0, which is represented by the red color line, and the voltage across the capacitor is initial voltage is E, so which is drawn using blue color line. Now the capacitor starts discharging through the inductor, and hence the inductor starts charging. You can see that the capacitor is sending a current through the inductor so that it is discharging, and the inductor stores the energy in its magnetic field. Hence you can also see that the voltage across the capacitor is dropping down and the current flowing through the inductor is increasing. Now after some time, the capacitor is fully discharged, and hence its voltage has reached 0. See, the voltage has come down to 0. At the same time, the inductor is fully charged and its current has reached maximum. Almost all the energy from the capacitor is now stored in the inductor. So we know that the inductor does not allow sudden change of current flowing through it. Hence, the current continue to flow in the same direction. Therefore, thereby the opposite action happens. That is, the inductor starts discharging and the capacitor starts charging in the opposite polarity as the previous case. Now you can witness this change with the help of waveforms here. See, the voltage has gone in the opposite direction and the inductor current start decreasing. After a certain time period, the capacitor is fully charged with opposite polarity, that is E. Earlier it was plus E, now the voltage across the capacitor is minus E. The inductor is fully discharged and hence the current flowing through the inductor becomes 0. So capacitor voltage has reached minus E and current is 0. So this process of exchanging energy between the inductor and capacitor continues to produce more number of oscillations. This is, see, like this. So this process continues, and this is called natural frequency of oscillation. This oscillation will continue and the magnitude of energy keeps dipping down due to the power losses in the internal resistance of the capacitor and inductor as shown here. Because all the inductors and capacitors are not pure inductors and capacitors, they have their own internal resistances. So when the exchange of energy happens, there will be a small energy loss in the internal resistances of those inductors and capacitors. Therefore, you can see that there is a dip in the magnitude of oscillations. So at one point of time, the magnitude of the energy will become 0. This is what the practical case. Now, if the supply frequency of the RLC circuit is matched with that of the natural frequency of oscillation of this tank circuit, then you can say that the series RLC circuit is at resonance, right? So these are some of the basics about electrical resonance. Hope all of you have understood the concepts clearly. We will discuss about the resonance in series RLC circuits in the next coming slides. Thank you.